Welcome to lesson 2-11. In this lesson we're going to be looking at derivatives of bases other than e of course being the base of the natural logarithm, approximately 2.71. We're going to apply the same properties of inverse functions to these derivatives that we have seen previously, and we're going to see how we can also apply these rules for derivatives for inverse trig functions. First, a real quick review. For any base b, so lowercase b is any real number and it's the base of a power. If the power is b to the 0, then what we have is 1, because anything to the 0 power is going to be equal to 1 regardless of what that base is. The only caveat to that would be b could not necessarily be equal to 0 because that's one of our indeterminate forms. So I guess I should say any non-zero real number. Here we have the product rule for powers, b to the x times b to the y. The product of two powers is equal to b to the x plus y. We add the exponents and have a power of the product. The quotient rule for exponents says that b to the x divided by b to the y is equal to b to the x minus y. Notice that in both the product rule and the quotient rule, the bases have to be identical. If you don't have identical bases, then you cannot combine them. Finally, we have the power rule for exponents, and that says b to the x to the y is equal to b to the x times y. Next, we have rules for taking the derivatives of both the powers and the inverse, which would be the logarithms. So the derivative with respect to x of a to the x is just equal to the natural log of a, the base, times a to the x. Analogously, if instead of x, if we have u, where u is some function of x, so we could write it like u equals f of x. So u is some function of x. If we take the derivative with respect to x of a to the u, then that's going to be equal to, just like before, the natural log of a times a to the u. But now we have to apply the chain rule and differentiate u with respect to x. And so we would need to find what du dx is and multiply. Next, looking at d dx log base a of x, that's just simply going to be 1 over the natural log of a times x. And again, if u is a function of x, if u is equal to some f of x, then the derivative with respect to x of log base a of u is going to be equal to 1 over the natural log of a times u. And that would be the original function without doing anything to it. But then we would need to multiply, again via the chain rule, by the derivative of u with respect to x. So we would need to take that f of x and differentiate it. This would be like multiplying by u prime. And so again, that's just the chain rule applied to this differentiation.